Hello everyone, my name is Vorakit. Today I'll be presenting on my final year project entitled Solar Radio Bus with Upgraded Half-Wave Dipole Antenna Array. In modern day life, we have to depend strongly on technologies which are vulnerable to solar activities. The research on solar activities and their impact on Earth is very important. Solar activities can affect human lives on Earth in many ways, such as widespread radio blackouts and long-lasting radiation storms. For example, the solar storm of March 13, 1989 caused transformer failure on power transmission lines in Quebec, Canada. 6 million people lost electrical power for 9 or more hours. One of the solar activities is solar radio bursts. Solar radio bursts is a phenomenon in which the sun projected its radio energy onto Earth. It is also a system of time-dependent frequency space. Most of the radio bursts can be recognized with low frequency from as low as 200 MHz. Solar radio bursts were the first phenomenon to be identified in the field of radio astronomy. By observing the frequencies of the radio bursts, they can be divided into 5 main types such as type 1 burst, type 2 burst, type 3 burst, type 4 burst, and type 5 burst. In our study, I mainly focus on type 2 solar radio bursts. Type 2 bursts are caused by magnetic shock wave following coronal mass ejections. This type of burst is also known as slow drift burst. Type 2 bursts have structure called herringbone, which is a rare occurrence, as we can see here in this picture. This structure is called herringbone because it resembles the skeleton of a herringfish. The objective of this project is to study the formation of herringbone type 2 solar radio bursts. For data collection, I mainly use NIH and eCallisto. Nancy radioheliograph, or NIH for short, is a T-shaped interferometer made up of equatorially mounted antennas of several meters. The instrument observes the sun 7 hours a day to produce images of the corona in the frequency range of 150 MHz to 450 MHz. Callisto stands for Compact Astronomical Low-Cost Low-Frequency Instrument for Spectroscopy and Transportable Spectrometers. Callisto is a type of radio spectrometer with worldwide usage for 24/7 observation on solar activities. In this study, I chose a solar radio burst event that occurred on November 3, 2010. This event showed a type 2 solar radio burst with the herringbone that I wanted. I start by collecting the data needed for my analysis. I downloaded the data from a few websites such as eCallisto, Space Weather Prediction Center, SWPC, and NIH. After I finish collecting the data, I start plotting the image of the spectrum, and this is what I get as shown in this picture. Based on the spectrum, we can see a type 2 solar radio burst with herringbone structure. This burst occurs from 1250 Universal Time to 1280 Universal Time, with frequency between 200 and 500 MHz. The purplish-black horizontal lines across the spectrum are radio frequency interference. The horizontal white lines, on the other hand, represent 10 NIH frequencies, which is from 150 MHz to 450 MHz, and are important for our analysis later on. The vertical white lines represent the selected analysis time, which is from 1250 Universal Time to 1280 Universal Time. Once we have the spectral image, we can proceed with our data analysis. For the data analysis, I use a programming software called SSWIDL. This software is used specifically for analysis of solar activities. Firstly, I analyze the radio sources of this herringbone event. By examining the overplotted image spectrum with NIH radio frequencies as shown in this picture, we can see images of several wavelengths and multi-frequency of the NIH radio sources. So, the dispersion of the radio sources based on the frequencies are indicated by each of the colors. These images can also work like an animation. So from the animation, we can see that the radio sources remain stationary throughout the event. This is because all 10 NIH frequencies lines up very well. Next, we examine the maximum brightness temperature of this event as shown in this picture. Brightness temperature is widely used as a measure of received intensity. We can see that the intensities of all the frequencies are above 10 power 8 Kelvin. The intensity at 150 MHz even exceeded 10 power 10 Kelvin for several minutes. We can also see that in general, the lower the frequency, the higher the intensity, and vice versa. Next, we examine the degree of circular polarization of this event as shown in this picture. We can see that throughout the event, the circulation remains steady at values between 4% and 52%. At the same time, we can also see that at certain frequencies, the circulations are negative, which indicate left-handed circulation. Once we have known the intensity and the circulation, we can determine the emission of this herringbone. Different types of emission have been summarized as shown in this table. We also listed together the physical parameters of our event. Based on the extremely high intensity, which is 10 power 10 Kelvin, this means that it is either fundamental plasma, second harmonic plasma, or ECM emission. Then we can see that the circulation is from 4% to 52%, which excluded that is originated from second harmonic plasma and CM emission. So the emission of our event is by fundamental plasma. Fundamental plasma emission is an emission in which the plasma radiation is generated by electron streams, whereby the electron stream produce a radiation at numerous frequencies. This is why the herringbone is produced across the frequency range, which is moving from higher frequency to lower frequency. This corresponds to electron stream moving away from the sun. As a conclusion, the herringbone structure of our event is generated from type 2 solar radiobus through fundamental plasma emission. This is important because herringbone is a part of rare feature in type 2 solar radiobus which can affect human lives on Earth. This is because herringbone can act like electromagnetic pulse or EMP that can disrupt and damage electronic equipment. Compared to 1989, people today depend even more on technologies. Power supplies, communication, and information storage are important. Disruption in this can cause unimaginable losses. Therefore, we need to have a general understanding of how this structure is generated to better prepare if such event in 1989 were to happen again. That's all. Thank you.